Voice clear? Is the voice clear? Voice is clear? It is still raining here, but not very thunderstorm. Suddenly it will come. I will start. In case it becomes horrible, then I will stop. Because I observed from past half an hour, 5 to 2-3 minutes rain, then it stops. So we can manage. If it is not audible, comment immediately. Okay, start. Now, as announced, write heading. Heading you should write conjugate beam method for finding slope and deflection beams. I won't write, space problem. Conjugate beam method for finding slope and deflection. See, one of the very easy method. Actually, it is going along with moment area method. But moment area method, you draw elastic curve, then decide which are the 2 points to be considered, see the intercept there, vertical displacement of this point with respect to tangent somewhere there. That all becomes confusion sometimes. So, conjugate beam method, all those confusions are not there. It is a very systematic method. Once I tell the principle now, up to end of this method, there is nothing. So, see, suddenly rain little started. Okay. So, I will tell first the principle of conjugate beam method. Actually, remember, this is a graphical method. If you remember, olden days, there used to be a subject called graphic statics. If you remember, subject called graphic statics. There, deflection is, slope and deflection is done by conjugate beam method. You draw the bending moment diagram, then that BMD area divide into parts, apply it as loads on another beam, again draw bending moment diagram. How you draw? By using funicular polygon. There is a procedure for bending moment diagram. The funicular polygon itself is bending moment diagram. Then, in the second bending moment diagram, that is that second bending moment diagram, directly you get what? Whatever required, you get there. If you remember, now the subject is not there, called graphic statics. Because nowadays computers all came, nobody wants a graphical solution. And remember, this method there is no standard type of proof. But what happens is, arguments are there. Even momentary also in your class, I told principle only. Same way, I will tell principle. Once these methods are over, when we come back to BSK class, remind me, I will tell that moment area. What is the first theorem, second theorem, and this principle. Okay, see. Now, procedure, once I write, correctly follow procedure. See, as I write the procedure, simultaneously, I will solve the first question. Simultaneously, I will start first question. See, moment area method, I first considered cantilever, then I considered simply support beam. Conjugate beam method, I like simply supported first, then cantilever. There's a reason. Anyway, for you hardly matters. See, principle of conjugate beam method. See, what you have to do is, bending moment diagram, BMD, for given beam. Given beam. I will tell you here, the term given beam means the beam for which we have to find slope and deflection. You know symbol, why waste time? The beam for which you have to find slope and deflection. So that real beam, in the bracket I will write, referred as means what? The given beam. See, this is the given beam. A simply supported beam of span L subjected to a load W at center. This is the real, this is the given beam. See, I write here, this is given beam. The given beam that is real is referred as real beam. See, real beam. Kannadadalli, Nijavada beam. Hindi, See, I don't get the word for Hindi. Real beam. Okay, leave it. Real. Sometime I won't get word in Hindi. Real means real. So, brackets are not to be seen for definition. See, bending moment diagram for given beam is means what? Don't see bracket. Bending moment diagram for given beam is considered as, very important, it is considered as loading diagram. Loading diagram. That is some type of load. Pure imagination. Loading diagram, in the bracket I will write. When you tell the loading diagram, it is either UDL or UVL. It can't be point load, remember. So, tell me how you define UDL or UVL by. How you define UDL or UVL by? First. सच्चा बीम, थैंक यू. सच्चा बीम, सच्चा झूठा, ये दूसरा झूठा बीम है. That conjugate beam is झूठा beam. Okay. No. I am telling. When bending moment diagram for given beam, don't see bracket. It is referred as real beam in future. E is considered as loading diagram. This is pure imagination in load. Remember, pure imagination. Sapna in Hindi, Kanasu, Atara. It is not real. Okay. Now tell me, loading diagram means it should be either UDL or UVL or higher order, parabolic possible. It cannot be what? It can be either UDL or UVL or parabolic or higher order. Tell me, how you define? That is, loading diagram means it is distributed load. Make a note. When you tell loading diagram, make a note here. It should be a distributed load. It can't be a point load. Therefore, it is distributed load. Either UDL or UVL or anything. Tell me, how you define distributed load? By what? Distributed load, you define by what? Fast. Distributed load, you define by what? This is known for you, not first time. If you see my SFD BMD course in YouTube, thousands of times told, intensity. So, when you tell a loading diagram, we have to define intensity. So, I write here, is considered as loading diagram. In the bracket, in the bracket I will write, with intensity of load anywhere equal to, if you want intensity, that intensity equal to BM for real beam. So I shortcut, BM for real beam there divided by EI. Close the bracket. Whatever is the bending moment you got here, divided by EI is the intensity. It is not total load. It is intensity. Now, brackets are for understanding. Go for main statement. BMD for given beam is considered as loading diagram. See, continue. Don't see this one. Loading diagram on means BMD is considered as loading diagram on an imaginary beam. Pure imagination. Kannadadalli ಊಹೆ, Hindi khayal, something like that. Pure imagination. That beam does not exist. It is a completely you can't even see that beam. Rain started. Imaginary beam in the bracket. Imaginary beam bracket called correctly for the first class only rain coming. Principal class. At least some 10-15 minutes. If it gives me free time, I would have finished everything. Okay, we can't do anything. Voice clear? This is disturbing. Voice clear? Rain actually spoiling everything. If there is no rain, I would have made much more clear. It comes and goes. Clear? Okay. See, on an imaginary beam, that imaginary beam is called conjugate beam. Okay. Then, if you do that way, then see, slope, that is theta. Slope is called by theta. Slope theta. Now, at least 15 minutes. Slope theta. Now 1 minute. Moment area method, slope you decide by tangent drawn and see moment area method. If you want slope, see the diagram, clockwise, anti-clockwise, etc. No, here standard format. Then slope always clockwise positive. So here you don't have to bother whether it is clockwise, anti-clockwise. Sign will tell you the answer. Clockwise at any point in real beam, in what? In given beam or real beam. See, real beam is black, conjugate is blue, is equal to, anybody can tell if you know it? Anybody can tell if you know it? Anybody can tell if you know it? Slope at any point in real beam equal to. Tell me. See, sometimes very interesting area. No. Interesting concept. In silence, I can tell very clearly. I have to shout and I have to put lot of effort. No area. How? No. See, blue color. Shearing force at that point in conjugate beam. In conjugate beam, sign convention, our usual sign. Be careful. Sign convention for shear force. This I will not explain because SFD BMD course thousands of times I told. Clear? Slope equal to shear force. Real beam slope is conjugate beam shear force. And deflection, that is y. In Macaulay's method, y is upward positive, but in conjugate beam method, y is downward positive. Be careful. downward positive at this is at any point in given beam. Given beam means real beam. Completely spoiling the class. Is equal to, anybody can tell? Slope is shear force. Deflection is what? You can imagine. BMD. BMD is not a value. BMD is not a value. BMD, how? BMD is not a value, it's a diagram. What is BMD? You don't calculate BMD. What is BMD? See, this is the problem. How it comes to the mind? Equal to BMD. BMD is a diagram. BM equal to bending moment, sagging positive. At that point in conjugate beam. Hey, Ryan, please stop for 10-15 minutes. Okay. This is the principle. Okay. Now I will give you procedure and some extra points I will tell you. Now onwards, repeatedly, I will not tell. In all the further class, I will tell. If you got doubt, refer to the first class. First class of conjugate. I forgot right there. Conjugate the method. I change the title. Conjugate the method part 1. Today's class is conjugate beam method part 1. Okay. This is the principle of conjugate beam method. Is it clear? Tell me, clear or not? I will make it clear now. Here, okay. Now, one important aspect. Note. I will not repeatedly tell this. I will tell only once now. Only once now. This you have to write very bold letters. Whenever, I'll do danger color so that people who don't study properly, they are in trouble now. See, red color, warning. Whenever there is a loading represented by a diagram, whenever there is a loading represented by a diagram, then for any considered length, any length, tell me total load, any considered length, total load. I will not tell again and again, there is a limit for explaining. Total load. For any considered length, total load. Total load. See, this I cannot tell each and every class. Any length considered, total load. Suppose I want total load. Answer. In the SFD BMD chapter, this is told lakhs of times. Not lakhs actually, maybe 100 times. Sufficient. Total load, first must. total load. If you don't answer, I will stop the class. If you do not know this one, it is waste area of the load diagram. Area of load diagram for that length. That length is the considered length, and line of action of that load will pass through what? Line of action of that load will pass through what? Will pass through. Line of action of that load will pass through. CG, correct. CG of load diagram or load diagram for that length considered. For that length considered. Remember, I will not tell again this one now. Once for all settlement. I will tell again now. See, I will tell you. You write 100 times. If there is a loading diagram, this anyway, either this way, either rectangle or triangle, any shape. If you want the total load, see, load means hand has to move like this. If you want total load for any length, see what is the area. See what is the area of that load diagram for that length. And suppose you want to know where is line of action, how much area you considered, mark CG of that much area through which the resultant force will pass. Settlement once for all. First of all, I should not tell this one. Why? SFD BMD. How many times I told this one? Fully clear? Full clear. It's rain today is spoiling like anything. Clear? Okay. Now, I will tell the procedure also. Okay. I will remove everything now. This you study thoroughly, repeatedly. Repeatedly study. This I am removing. This I am removing now. See, you take a photo and maintain. Okay. This much trouble rain is going to give, I don't know, it has got some effect. I don't know what is the reason. Whenever I start something new, it will come there. You don't know how frustrating it is. Okay, what to do? Nature. Okay, now, I will give you procedure. Procedure. Will not repeat. First, draw the given beam. Given beam, that is called real beam. Real beam for which we have to find slope and deflection. Okay. See, my first question, I will start here. My first question. Question number 1. First question. Same way, a simply supported beam. Okay, this is it. When I want black color, black will not come. A simply, question number 1. Question number 1 I am telling. A simply supported beam of span L. I will put the beam simply supported here. I will call AB span L. is subjected to a central point load W at center. So central load means center only. Central load of magnitude W or P, today W. So at L by 2. Let it be C, center. Question is, find maximum slope and maximum deflection. Maximum slope and maximum deflection. If you remember earlier by moment area method, this answer we got WL square by 16 EI. This deflection, if you remember, WL cube by 48 EI. Do you remember? Tell me. Do you remember? This is a standard answer. Do you remember this one? Long back solved. Okay. Now, that also extra. Sorry. Now, extra. Extra is for concept. Extra will be also find slope and deflection at two new points. Say a point called P1, another point called P2. Same thing I did in moment area method. P1 is at, I remember, before coming the class, I saw the moment area class just now. I remembered P1 is at L by 3 from left hand. I remember. And P2 is at L by 5 from right hand. Right hand. That means what? Your beam is like this. This is the beam. If I call A, this is called B. Load is called W. Span is L. Load is at center, L by 2. This is C. They want theta max. I already told the answer. They want Y max. And then extra 2 points are there. One of them is here. P1 at L by 3 from here. And another point P2 at L by 5 from here. Remember, same question we solved by Macaulay's method and also moment area method. Do you remember? Do you remember? Same example we considered in Macaulay and moment area. Yes. Now, I don't remember the answer, but not a problem. See, I will write now only, make a note. At that point P1, theta and Y. Five by 144 WL square by EI. Clockwise. Deflection. (23 by 1296 WL cube by EI). And at that point P2, slope. That point P2, slope. (21 by 400 WL square by EI). See, danger. Giving answer before starting is danger. If something goes wrong, I am in trouble. And deflection. What is this one? Oh. Some rock. (71 by 6000 WL cube by EI. Now, do you remember this answer long back we got? Anybody remember? This answer we got long back. Now we will solve the question. This is just to give you confidence. Okay, start. I am removing. You make a note. When I can't remember the values. When I solve the question, I can't remember any one of them. I will ask you, what was the given answer? You type same, that's all. The slope is anti-clockwise, deflection is down. Okay, over. Now, start solving the question. See, now those who want, write step-by-step procedure. Draw the given beam, that is real beam, for which we have to find slope and deflection. That is this beam only. Okay, now, if required, find reactions. If required, find reactions at supports and enter. When required, when not required, I will tell you later. You know it. Okay. Now, for our question, see, this is a procedure I am giving. When I start my first question, you can write for the given beam, that is called real beam. Reaction VA equal to reaction VB equal to total load on given beam. Be careful. Given beam divided by 2, load is W by 2. So each of the reaction is W by 2. Fully clear? I don't have to ask. Full clear or not? Let the question be systematically over. I will make the question systematic today. Rain trouble, let it come, no problem. As long as my voice is audible for you, we will continue. Clear? Okay. Now see, I will start solution. I entered the real beam here. Real beam is, see, given beam, actually given beam, such a beam. But in this method, it is called real beam. Nodi. A, B, C. W by 2, W by 2. L by 2, L by 2. Very neatly, I considered the real beam with the reactions. Okay. Then, next step. See there. Now, next step, I will put step here. Draw BMD for real beam. Real beam is given beam. Draw BMD on real beam. Very important. Very important. This time is for conjugate beam method with sign. Sign required. That is sagging positive. Sign is very, very important. Momentary I could remember, we never bothered sign. Okay, now, second step. You should write the step separately. I am writing mix-up. What you do? Later after the class, how I explain, separate page write principle, separate page write procedure, then start the question. Okay, start. Now, see now, this question. For the real beam, I already told you, VABB. See, I entered here, W by 2. We want BMD for real beam. If you want so, side by side calculation. See, BM at A equal to 0 equal to BM at B. And BM at C equal to, look that side, W by 2 into L by 2. Plus, here also plus. Plus, W by 2 into L by 2 equal to plus WL by 4. Enter. Linear variation. 0 here, 0 here. WL by 4 here. Linear variation is the BMD for real beam. Up to this step, fully clear? Up to that step, fully clear? Once you understand, this question is nothing. See, you will laugh later. If you thoroughly understand, later you will start laughing. This question, this much explanation, yes. When you explain thoroughly everything and everything goes inside, then only knowledge will stay. Okay, now, what I will do is, Okay, leave it. Now, next step, I will write here. This all I will remove now. I will continue procedure now. Here, next step. Draw BM by EI diagram. Whatever BM you got, divide the ordinate by EI and draw BM by EI diagram. Start. This is child work. Somebody in the high school can do it. Bending moment 0, 0 divided by EI 0, 0 by EI 0. WL by 4 by EI becomes WL by 4 EI. So this is what? Your BM by EI diagram. See, make a note. To get the BM by EI diagram, variation is same as BM. Every ordinate to be divided by EI. And once again, the shape will be same as BMD if EI is constant. But only thing is, that is a BMD, this is BM by EI diagram. This step also clear? Fast tell me. This also clear? I want clear. BM by EI diagram. Little fast, don't waste time. I had to finish before 9 o'clock. Okay, clear. Next step is very important. Next step. Below that BM by EI diagram, which is just now drawn, below that diagram, draw conjugate beam, which is pure imagination. Remember, pure imagination. That beam is not there. Pure khayal, swapna, atava kanasu. Pure imagination. See, I will draw blue color. This is the conjugate beam. I wrote here. This is the blue color conjugate beam. Okay, now one important aspect. For the conjugate beam, consider above drawn BM by EI diagram as what? Tell me. As what? I already told the principle. For the conjugate beam, above drawn BM by EI diagram is considered as what? Is considered as, I already told you. For the conjugate beam, above drawn BM as loading diagram. Oh, one thing forgotten for me. I will tell now. One important concept forgotten. You add the principle. See that box. I forgot. Loading diagram. Okay. Remember, intensity anywhere equal to what? BM by EI there. Correct? Anywhere you want intensity, it is BM by EI there. Okay, now one's very important. See, if for real beam, if BM is sagging or positive, that is positive, then loading for conjugate beam will be downward. If the BM is plus, it is downward load. Whereas if BM for real beam is hogging, that is for us negative, then same thing, then loading for conjugate beam is upward. If plus sign is there, take downward loading. If minus sign is there, take upward loading. Again, this one I forgot. You enter this one in that main box. Remember, first I told one principle. See, full box I given. BMD for real beam is considered, slope equal to shear force, etc., etc. I told you. There, enter this also. Clear now? Somewhere there, after everything is over, enter this also. Clear? There, enter this also. Okay? This also enter there. Clear or not? In that statement given earlier, enter this one. You are not responding. This statement, enter this also there. You see later how easy the method is. Okay, now I will tell lastly, if this BM is plus, downward. If this BM is minus, upward. So tell me, therefore, for our conjugate beam, this is the loading diagram. Load direction is down or up for our problem. It is plus is there here. So for our present case, see, when you go to cantilever, negative BM will come, then up will come. So for our beam, this is plus here. So the loading here is down or up, first, downward. So, and accordingly, mark arrow, close arrows. See, this way. If you want further close arrows, okay. This is the loading for conjugate beam. Okay. Okay, now, next step. Also, mark supports for conjugate beam. Supports for conjugate beam. Conjugate beam. Now, this I will discuss tomorrow. One big page I will give you. Real beam to conjugate beam, when you go, support condition varies. Today not required. Believe me, see. Real beam, if simply supported, then conjugate beam also is simply supported. Tell me, enough for today? Enough for today? Tell me. Today sufficient or not? I will tell you about cantilever, overhang or later. Real beam, if support is simple support, conjugate beam also, support will remain same. So simply supported beam, there is no change of support. Simply, if the given beam is simply supported, conjugate beam also is simply supported. So you believe me today. Enough for today. Next class I will tell the list how is the support changes. Today no time. Okay. Now, so mark support. See, I mark support for conjugate beam. And I told you, mark support for conjugate beam. And if required, sometimes not required. That is for cantilever. So do one thing. These all will come one by one. If required, find reactions for conjugate beam. Find reactions for conjugate beam. Remember, there, if symmetry is there, use symmetry. Tell me. For our case, sorry. And also do one thing. Add one suffix C. When you write VA for real beam and VB for beam, when you come to conjugate beam, just to change it, you make it VA dash and VB dash. Put one dash to indicate that it is imagination. See, this is real VA, real VB. This is VA dash and VB dash, pure imagination. Clear? Suffix point of view, consider dash extra. Clear or not? Suffix point of view, consider one dash to show that it is imagination. Okay, start. Now, tell me, is this symmetrical loading or unsymmetrical loading? First, is this loading symmetrical or unsymmetrical? This loading, symmetrical or unsymmetrical? Symmetrical. So do one thing, directly write. Due to calculation of reactions for conjugate beam, see, due to symmetry, VA dash equal to VB dash equal to total load on conjugate beam. Don't see that beam. Total load on conjugate beam by 2. I told earlier, I am not telling once again. For the conjugate beam, loading is uniformly varying load. I told 1,000 times. If you want to load, tell what you have to find. I will not tell once again. If you want total load for a distributed load, tell what you have to find first. I will not tell from next class onwards. If you want total load, what you have to find? Next class onwards, I will not tell. Area. You write if you want. When you want load for conjugate beam, it is area of this BM by EI diagram equal to full load, half into full span L. L into WL by 4 EI is the area, that is the total load. See, half into L into WL 4I is the area of the load diagram right there. This is the area of the load diagram. That itself is the total load. Divided by 2, you get WL square by 16 EI. Correct or not? Not correct. You get WL square by 16 EI. Go back and enter the reaction. Oh, somebody already entered here. Of course, this is not given calculated value. Go back and enter the reactions. Full clear? Tell me. Full clear means I will go to one by one now. If it is clear, I will go to next step. If clear, tell me next step. I will go. Now over. Not much time. I think 15 minutes, this question will be over. Okay. Now, if you understand correctly, to reach here, you require 2 minutes. To finish the question, you require another 2 minutes. That's all. Okay, now, start. Now, find whatever is required. Start. Our question. To find maximum slope and maximum deflection for what? For real beam. Real beam means what? Given beam. Okay. Start. Do not say conjugate beam. Our real beam is simply supported, central load. Beam will bend this way. This is theta A. I am not showing direction here. Theta B, deflection at C. See, I told you 1,000 times. What? This theta A, theta B are maximum slope. YC is maximum deflection. So start. First, theta max equal to theta A or theta B, whichever is higher. All for real beam, whichever is higher. Conjugate beam is used only to calculate. Any discussion is for real beam, higher. Now, due to symmetry, theta A will be equal to theta B. Therefore, find only one of them. Find anyone. Find, say, theta A. Start. Theta A clockwise in real beam. Tell the answer. As per conjugate beam method. See, now onwards, in the real beam, if you want slope, in the conjugate beam, find what? Permanent now. Real beam, if you want slope, in the conjugate beam, find what? Or for the conjugate beam, find shear force. If you want deflection for the real beam, then for the conjugate beam, find what? Find. If you want deflection for real beam, conjugate beam, find bending moment. That's all. So start. Shear theta A clockwise in real beam equal to shear force at A in conjugate beam. Conjugate beam. Sign convention, left up dash dash dash, right down positive equal to, if you want slope here, come to conjugate beam at A, slightly come inside, look this side. Shear force is left up is positive, it is plus WL square by 16 EI. See here, shear force. Therefore, your theta A equal to WL square by 16 EI, plus means clockwise. That is the slope at A. Then without calculating right, due to symmetry, if you want theta B, it is same WL square by 16 EI anti-clockwise. See, because right up is negative. Therefore, conclusion, maximum slope for the beam, slope for given beam or real beam equal to WL square by 16 EI, where at supports. Tell me, maximum slope, fully clear? If fully clear, I will go to now maximum deflection. Maximum slope, fully clear? You are not answering. Full clear, maximum slope? Okay, now go to next one. See, same diagram. Next, to get maximum, or already told, Y maximum, why waste time? Y maximum for given beam. Given beam means what? Real beam, RB. Start. Due to symmetry, Y max for real beam will be at center, that is at C. Therefore, your Y max will be deflection at C for real beam. Maximum deflection will be center. Start. Now, to get YC down in real beam equal to bending moment at C in conjugate beam. Sagging positive equal to, if you want deflection here, find bending moment here. Remember, bending moment here. This is not bending moment. This is the loading diagram. It was the BMD for real beam. For conjugate beam, this is not the BMD. This is a loading diagram. I want BM at C. See now, deflection here is bending moment here. Look this side. WL square by 16 EI into L by 2 positive plus WL square by 16 EI into L by 2 positive minus moment of this uniformly varying load 0 to WL by 4 EI. Total load will be somewhere here. See, for this total load, resultant load will be here. That load equal to, I told you, I am not going to tell now onward. Tell me, total load equal to. Last time I am asking. Next time I will not talk. Total load equal to. Next time I will not talk about this one. Leave it. Sufficient. I told already 100 times today. If you want distributed load, total load equal to. Fast. Distributed load, if you want total load equal to. How many times I have to ask? Area. So, total load equal to this area. How much? Half into L by 2 into L by 2 into WL by 4 EI. Only half the area. This is the total load. We want bending moment here. See, that reaction into L by 2 minus this total load into this distance. Tell me. It is BM at C we want. From here to here. Is it 1 by 3 or 2 by 3? First of all, I should not ask. Is it 1 by 3 or 2 by 3? Is it 1 by 3 or 2 by 3? It is 1 by 3. Why means, if it is not clear, don't come to my class. 1 by 3 of L by 2 or equal to WL square into L is WL cube. Here also L into L cube by EI times 1 by 32 minus 3 6 6 4 24 24 48 96 1 by 96 or equal to plus WL cube by EI into, tell the number, 1 by 32 minus 1 by 96. Tell the number. You know the answer. 1 by 32 minus 1 by 96. Answer. 1 by. Tell me. 1 by number. 1 by 48. 1 by 48. 1 by 48. Therefore, presentation. See. Deflection at C for the real beam equal to WL cube by 48 EI, downward positive came that much downward, itself is Y maximum. Therefore, presentation, maximum deflection for the given beam, deflection for your given beam is how much? WL cube by 48 EI, where? At center. Tell me. So completely clear how to find theta max and Y max. Now I will go to two more points. If it is fully clear, I will go to extra point. Usually, most of the exam point of view, they want only maximum slope and deflection. Extra points usually people don't ask, but rarely for engineering service or gate they may ask. Otherwise, for PWD, this one, that one, PGCET, all, they don't ask those things. Clear or not? No. What you have done so far, clear? You are not telling clear or not? What you have done so far is clear. You are very late in commenting. What is, because I want to confirm that audio is clear. Okay, now I will remove everything now. I will close the question. One point I will do, other point you try in the class. I will take a small break at that time. See, now already I told the answer to you. Remember. Now see, now right here. Now for the beam, we already got the main part, slope and deflection maximum. Now that extra part, that first already marked. I will use red color. Calculation of slope and deflection at P1. That is a random given point. It is a given point where at L by 3 from A. Okay, don't think. One note. Go back and without disturbing already entered values, mark P1, mark that point P1, and also information, and also whatever needed, whatever required at P1. See now what I am doing. This I am removing. Okay. Sorry. I will remove this one completely. This is not required now. Actually, if extra points are there, what you have to do is here, little space you have to leave. Okay, now see. I will do one thing now. Without disturbing P1, oh, ಇಲ್ಲಿ ಇದೆ. Don't disturb main marking. Red color I will use. Oh, ಇಲ್ಲಿ ಇದೆ. P1. Light kind P1. Okay, new point. As per the question, it is at L by 3. Now, first I want BM at P1 for real beam. I want what is this ordinate. Okay, that ordinate is what? Look this side. W by 2 into L by 3 plus W by 2 into L by 3 equal to WL by 6 positive. Enter it. Without disturbing, enter. WL by 6. Then also enter what is the corresponding ordinate here. Corresponding ordinate here. If it is WL by 4, this is WL by 4 EI. If WL by 6, this ordinate is what? WL by 6 EI. So right here. Therefore, enter intensity in conjugate beam loading. How? Whatever BM is there by EI. Now, look only this side. Look only this side. Start. Here also. Without disturbing that point P1. Light line P1. And see, come down. Hey, right. Somewhere here is P1. P1. P1 is here. From here to here is L by 3. Okay, start. Now, and enjoy the calculation. Start. Slope at the point P1 in real beam equal to what? Clockwise positive. Shear force at P1 I'll do one thing now to save time. Now onwards, real beam I will write. Okay, today I will write. Next time, theta P1 in. Today I will write real beam clockwise positive equal to shear force at P1 in conjugate beam. Next time I won't write in conjugate beam. Left up dash dash dash, right down positive. If you want slope here, it is equal to shearing force here. Shearing force here, look this side. When you look that side, left up is positive. Plus W, no distance now, only shear force. WL square by 16 EI, no into Y, only force. Then minus this much load equal to half into L by 3 into that intensity is WL by 6 EI over. Tell the answer. L square 1 by 16 minus 1 by 1 by 16 minus 1 by 36. Answer plus. Take your calculator. 1 by 16 minus 1 by what? 1 by 16 minus 1 by 36. Answer. Fast. 5 by 144. It is plus, or I write here equal to plus, or WL square by EI into plus 5 by 144. Therefore, answer. Slope at the point P1 equal to 5 by 144 WL square by EI. Clockwise positive came that much clockwise. And next, deflection Y at P1 in real beam downward positive equal to bending moment at P1 in conjugate beam sagging positive equal to deflection. If you want here, we want a bending moment here. Look this side. Plus WL square by 16 EI is the load into L by 3. Now load into distance minus moment of this load half into L by 3 into WL by 6 EI is the total load, half into L, only L by 3 into the moment about P1. Tell me, for this much triangle, CG will be here. When you take moment about P1, from here to here is 1 by 3 or 2 by 3. Last I am asking. The distance from P1 is 1 by 3 or 2 by 3. I am asking last question now. Is it 1 by 3 or 2 by 3? Today's last question. 1 by 3 of what? Into what? 1 by 3 of this distance, that is L by 3. Or if you calculate, it will come WL square by EI times 1 by 48 minus, calculate half in 2 into 3, 6. So calculate 3 into 3, 9. Who will calculate this one? Baba. 2 into 3 into 6 into 3 into 3. 1 by 324. Our answer is WL cube. L square into L is L cube. Our answer is WL cube by EI into, tell the number, 1 by 48 minus 1 by 324. Answer. 1 by 48 by 1 by 23 by 1296 into plus 23 by 1296 is the answer. Therefore, you can present the answer what? Therefore, your deflection at the point P1 equal to 23 by 1296 WL cube by EI downward is the answer. Now tell me, in the beginning of the class only, I calculated using my trick. So I see that was my trick. You don't worry. Whether same answer given by me or different answer. Tell fast. In the beginning of class, when I gave the question, I told answer has to come this much. See, my class, once I tell, once I announce, answer has to come that much. Unless calculation mistake is there, it is impossible to get different answer. Same, okay. Now, see now, okay. Extra, second one, second extra. Calculation of slope and deflection at P2. That is at L by 5 from B. From B. Do one thing, same thing, go back. Mark the point P2 and also required at P2 without disturbing. Come here. L by 5 is somewhere here. Okay, P2. Do not disturb anything. P2. P2. This is L by 5. I require that ordinate here. Okay, start. Bm at P2 is said W by 2 into L by 5. L by 5 equal to plus WL by 10. Enter. This is WL by 10. Then this intensity here equal to WL by 10 EI. Right there. Intensity becomes that one by EI. Then without disturbing, light line here, P2. Now you are a rare point. Come down, mark here. L by 5. Now, same as last time, can you find theta P2 is shear force P2, BM at P2 is BM at slope at P2 is shear force at P2, deflection P2 is BM at P2. This value will change. Shall I take some 3-4 minutes break? By that time, can you correctly rough sheet? Can you calculate these two and type? Are you getting the same answer I told earlier? I don't remember. I will calculate once again what is there. I am so sure that theta P2 equal to 21 by 400 WL square by EI. It is anti-clockwise. And I am so sure deflection at P2 is 71 by 6,000. Tell me, is this value that now I wrote, I found once again, is it the same answer I wrote earlier? Tell me, these two answers at P2, is it the same answer I wrote earlier? Tell me, is these two values I wrote just now, is it the same answer I wrote earlier? Okay, now can you try in 10 minutes there? Because of the non-stop talking, now rain has fully what? Gone. So if you can calculate 5 minutes time I will take, then I will come and give a recap for you. I will explain the procedure once again for you so that there is no trouble. I will come back and I will explain this one. Then, or if not today, tomorrow before starting, I will give a recap of everything once again. That is the final. Then onwards, anybody, if not clear, I will tell, pay the penalty for not showing dedication. That's all I will tell. Okay. Can you try? Oh, already someone told, got it, good. Still, give me 2 minutes time, breathing time. At least 2 minutes breathing time for me. Because I am talking non-stop for 1.5 hours. Just 2 minutes. Okay, no problem. Others calculate. Others all calculate. Okay. Just 2-3 minutes I will come back. Okay, I will close the question. Hope by this time you got the answer. Everybody, those who are present, not present, only very few are commenting. So many people who are coming, they don't talk or they don't comment. I don't know why they are not commenting. Silently seeing, put your views. Put your views, let me know. Just coming and going, that is actually no use. It is actually no use. I am not happy. See, when I see that later after the class, so many people watched. I won't feel happy. I will feel happy by seeing how many people participated. That counts. Not the number of views. Sometimes number of views goes, I have seen, by the end of the class, it goes beyond 800 sometimes. But okay, but that means what? They are not seriously participating. I want only serious people and learn everything. Okay, I will explain briefly here. Be careful. Chance of making mistake. See, slope at P2 in real beam equal to shear force at P2 in conjugate beam. Look this side. When you look right side, here also look right side. SFD, BMD class, I shouted class after class. Left side upward positive, right side downward positive. I don't know how many times I told. So answer is what? Answer is, see, minus WL square by 16 EI plus this much load. That load is half into L by 5 into WL by 10 EI, or WL square by EI into minus 21 by 400. Therefore, theta P2 is 21 by 400, WL square by EI anti-clockwise. See, anyway, see elastic curve. This side point, slope will be anti-clockwise. You can make out. Next, deflection at P2 for real beam equal to bending moment now, load into distance at P2. Now bending moment, no clockwise, anti-clockwise, sagging positive, plus WL square by 16 EI into L by 5 minus moment of this load, half into L by 5 into WL by 10, half into L by 5 into WL by 10 EI into moment about this point here, 1 by 3 of L by 5. 1 by 3 of L by 5. You calculate, I don't have no time, equal to WL cube by EI into plus 71 by 6000 will come. Got the answer correctly? It will come plus 71 by 6000. Answer came. Therefore, deflection at P2 equal to 71 by 6000 WL cube by EI. See, tomorrow class I will go for a numerical problem. Same thing. But I will do one thing. Because it is a repetition, before the class, full board, I will write everything. Okay? And only explain. Why? Because once WL is clear, a beam of span 20 meter loaded by a load of 60 kN center, find maximum slope and deflection, also find slope and deflection at 2 points. So tomorrow, before the class, I will fill up the board and only explain. Then I will go to UDL and 2-point load and eccentric point load. Remember, moment area has got complications. Conjugate beam method, no complications. Very, very easy in conjugate beam method. Okay. And in conjugate beam method, we will consider it more cases also. Everything clear so far? Tell me. Everything clear so far? Class, tell me. Everything clear so far? No. Everything clear. Now, I will continue next class. In the group, I will send a message. Information for the BSK batch. Others, you see the notification, and when the next class is announced, come to the class. Only for BSK batch, right now, I will send a notification. Now, send a information. I don't have to tell here because why? So many people are there. Why should they know? For the BSK batch, after the class now, I will send a message for you. Some information. Okay, thank you. See you in the next class.